This one looked pretty easy. Okay, making a meowth. Meowth. I don't know. Anyway. So the idea is we take in continuous energy. The amount of times we spend together. So we got a situation where this guy reads every 4th page, I read 10, no matter what. Right? So we need to keep track of the amount of pages we read together. So what we'll do is loop it and have every iteration be a page. And we say every time we iterate, we go to a new page. Okay. God, it's fucking cold in here. So, okay. So we go to a new page. So we gotta know if it's a certain, we gotta know what page it is. So we start on page 1. Let's say if we mod page with however many pages he'll read, and if that is 0, then the idea is that if that's 0, then the idea is that he is supposed to read that page. So then what we're gonna do is we're gonna have a time variable. Let me change the data type on this because just to be safe. So we say if it's 0, that means it's in the first test case the 4th page, and if it's the 4th page, then we will increase the time by the amount it takes him to read his page and flip to the next page. If this isn't true, that means we have to read it. 2 things need to happen. 1, the time needs to increase by however much time it takes us to read. And not only that, we need to keep track of the number of pages we've read, because we're only willing to read a certain amount. Okay, so now this is where we need to think of it logically, right? So the idea is we need to break out of this loop after we've read all of our pages, except we need to keep in mind that there could be situations where we're done reading, but we let the Pokemon read or whatever. And so in that case, what we need to do is we need to check after we do something. So let's say if we start this and we say the amount we've read is now, or if we say if we read one more, or even this, if the amount we read is, greater than or equal to the amount we said we'd read, which is P, then we break. Otherwise, we go ahead and let them read that page. Oops, yeah, P, that's fine. And then we just show the times here. Time in Del fashion. And we have got ourselves a valid solution, I believe. So let's go ahead and test this. What we'll do is we will main.cpp, output it as main, not CP, it's C. And test it. Input test case. It's testing this case, which is 3. Let's go ahead and throw this test case in here. Let's keep that up. Let's go ahead and throw this test case in there and see if we get something similar. 29. Okay. Just to be sure, let's throw this guy in there. 8. Alright, looks like we got a valid solution, so let's go ahead and submit this. Well, looks like that's a valid solution. Now, as you can see, the time that it took the solution to run is relatively high. So, there's a possibility that this can be, well, not a possibility, there is another way to do this that's more efficient. However, for our purposes, since we're just kind of speed running questions, that'll just be fine for now. So let's go ahead and move this to solved. And we'll go ahead and find ourselves a new one to do. Let's try this one, eligibility. Every year, students across the world participate in the ICPC competition. In order to participate in this contest, the student must be eligible to compete. This problem, you'll be given information about students, and you will write a program to determine their eligibility. We will start by assuming that each student meets the basic requirements as specified in the rules. A student is willing to compete at the World Finals is a registered student with at least half-time load, competes for only one institution a year, and has not competed in 2 World Finals. Okay. The rules decide if a student is eligible to compete in the contest in year 2014-2015 is as follows. If the student first began post-secondary studies, so we're given all these constraints here, we'll look at those later. For equivalent of 8 semesters of full-time study, we consider each semester of full-time study to be equivalent to a student completing 5 courses. Thus, a student who's completed 41 courses is considered at more than 8 semesters. Okay. The input consists of a number of cases. The first line is a positive integer, and each of the case specified by a one-liner named name of the student. The first date given is the date they first began studies. The second date is the student's date of birth. Courses is a non-negative integer indicating the number of courses a student has completed, and there are at most 1,000 test cases. Okay. Coach petitions. So this is a parsing question. Let me check a couple things. One, So basically, we're just kind of going through all of these cases and seeing kind of which ones are successful and which ones fail. If the student began post-secondary studies in 2010 or later, the student is eligible. If the student is born in 1991 or later, the student is eligible. Okay, well, it really only matters. This is the only one that can make you ineligible. So what we'll do is we'll just go ahead and kind of get this ready for coding here. Let's do this. Let's set up to get the correct input, so call that test cases. And test cases, we're going to get some data, very specific data for each test case. So we're going to go to M, so we're going to get a string name. We're going to get, I'm going to take all these into strings because I can parse through them later. So here is date, full-time studies, date of birth, and I guess the last one I can take is an integer. Courses. Okay, so let's take in all the information. Okay, so we got all the information, and we can actually tell eligibility right here. We don't need to put them in a list or anything or do any manipulation with them. So what we'll do is we'll just kind of go through the constraints that are listed here, and just kind of test each case until we find either an eligibility or coach petition. Yeah. So let's find okay, we're given a year first. That's actually decent because we need it. So we can extrapolate year started college is date full-time study is a substring from 0, and we need the first 4. Similarly, year of birth is DOB substring from 0 to 4. So once again, we have the years here. Actually, what we'll do is we'll make those integers, because that'll make it easier for us to do the calculations. So we have a string here, string to int function will be utilized here. String to int, great. Okay, the year started college. That's awesome. We can actually do the first. We can do the first 3 test cases. Actually, we can just finish the problem. So, let's do the first one first. Year started college is less than 2010, right? Because if it's less than 2010, the student is just flat out ineligible. So we're doing something called control cases here. Control cases are the idea that if you have some logical order of instruction, usually given in like if statements, it is better to actually reverse the polarity of your logic and change true statements to false statements, because false usually means that all the other instruction after a false statement, like in this case, is going to be false anyway. So why waste the time in parsing all the way through it if you find yourself in a situation where it's just moot? So what we're going to do is we're going to check if it's less than 2010. And for that, student's ineligible. And we can actually return. So we only need to, actually no, we don't return, we continue, because we have other test cases, so it's going to go to the top of this loop. But we need to write the name, this form right here, the name, space, eligible, or, and that's a perfectly about it. And actually it's not eligible, it's ineligible, sorry. And that's a perfectly fine. Okay, second one, real quick. If the year of birth is less than 1991, same idea, ineligible. And I guess we could merge these two just to make things cleaner. So if, so if this one isn't true, they're ineligible, or if this one isn't true, they're ineligible. And here's another one. Let's see. If none of the above applies, so now we're moving on. Wait, what do they mean by apply? I actually don't know. I think what it means